Alright, so here we are on number 28. This is our next video example. And this one's a little bit different from number 26 in that there's actually three triangles. So I've got this large triangle, you can see. I've got this medium-sized triangle right here. But then I also have this very small triangle down here. And so I want to choose two of these that I can show to be similar so that I can then set up and solve for my x. So I'm going to use my medium-sized one and also my large triangle, and the reason why is because both of those have right angles, so it'll be easy to prove that those are in fact similar to each other. So I'm going to do that first. And I'm going to start by saying, since they both have right angles, and all right angles are congruent, so that's one set of congruent angles. And then I have the angle up at the top that they share with each other. And I can say something about that being the same angle. So now I'm confident that these triangles are in fact similar. So I'll go ahead and sketch them out separately. So I've got my smaller one and the larger one. And, just to distinguish them, you might decide that you want to do some dashing on this one, just to sort of distinguish the smaller one from the larger one. It's up to you. That's really optional. You don't have to do that. I do, though, want to add in my right angles, and I also want to add in my congruent top angle. Now for the small triangle, the side length here will obviously be x. The one at the bottom is a little bit trickier because I'm looking for this length, but I can see that it's going to be the same as this length. If it's not, then we're going to have trouble solving this problem. So this side is going to be 100. Looking at the entire length here then of the large triangle, it's going to be simply 125. And for this other side of the large triangle, I'm going to need to use the x and the 20 being added together. And so therefore it'll simply be x plus 20. Alright, now you can see there's something different here. As opposed to before where we had all the pieces except for the x and we could then just do our bridge to the x. In this case, the thing that I'm going to bridge to the x from also has an x in it, so that makes it a little bit more confusing. But I'd recommend that we just stay consistent and we still go build our bridge towards the x. We could have built it the other way, it doesn't really matter, but let's build it this way, and I'll show you how this works out. So that'll be my scale factor r. I'm going to find it up here. So r is equal to my L new over my L old. Because of my direction going from right to left, that means I'm going to be putting 100 over 125. So I can do that right here, 100 over 125. And then of course I can cancel that. 25 goes into 125 5 times and into 100 4 times. So more simply, r will be equal to 4/5. Alright, so now I can go ahead and set up to find x. And my equation is going to be that x is equal to r times the side that it came from, which was the x plus 20. Substituting in, I'm going to find that x is equal to 4/5 times x plus 20. Now I could try to distribute 4/5 into both of those. That's going to create a little bit of a mess though, so I would recommend instead simplifying the equation by multiplying both sides by the denominator of this fraction. So if I multiply this side by 5 and multiply this side by 5, that will give me 5x equals, here the 5's cancel, and so therefore I'm going to be left with 4 times x plus 20. Now I can go ahead and distribute that 4 to both pieces. So distributing here and here is going to give me 5x equals 4x plus 80, and then subtracting 4x from both sides. And also be left with x equals 80. And that should be 80 meters. And if I wanted to check and see if that made sense as an answer, that means that this would be 80 meters here. And this would be 80 plus 20, or 100 meters. And that seems reasonable because that still is a reduction going from my 100 to my 80, just as I was a reduction going from the 125 to 100. Alright, so that one was a little bit tricky. The next one actually is a little bit more simple again. We're back down to 2 triangles. So here's the sketch. The thing to be careful of with this one is to recognize that this 80 doesn't stand for this piece, but rather stands for the entire length, whereas the 30 only stands for this piece of my triangle. Alright, so start by identifying how you know that the triangles are in fact similar to each other. Then break out your 2 triangles and solve for x. After you've solved this, you should find that your answer here is x equals 18 feet. So if you get to the end and you did not end up with 18 feet, then go back and check your work and see if you can figure out where you might have gone wrong.